Okay, so today I'm going to teach you guys about double angles, and this is straight out of your textbook, Advanced Mathematical Concepts by Glencoe. So if you need to look back at the examples that I'm talking about now, they're under 7.4. So don't be afraid to look back, it's really helpful. So we have, for double angles, an identity for sine and several identities for cosine featured in our PowerPoint, and an identity for tangent as well. Today I'm going to show you an example with sine and cosine, since they are the most commonly used ones in your Precalculus course. So the only identity for sine of double theta is 2 sine theta cosine theta. And one of them for cosine 2 theta is cosine squared theta minus sine squared theta. This will come in our second problem. This we're going to use for the first problem. So we have a given information that sine theta equals 2 over 3. Now we know that this is in the first quadrant because it's both of these are positive, and our book also tells you that it's in the first quadrant. So if you want to solve the exact value of that function using your double identity, your double theta identity, then we are going to have to figure out what cosine is, because there's a cosine part of our equation. Now, if you know sine is in the first quadrant and it equals 2/3, sine theta equals 2/3, then you can approach finding cosine by using one of your trig identities. Now, if you remember to previous units, we know that sine squared theta plus cosine squared theta equals 1. This is very useful. Don't forget this piece of information because it often comes up in equations as well, and you'll be able to substitute different parts for 1. Because if you have a sine squared and a cosine squared, you can just put a 1 in there and it makes your life easier. So if we know sine is 2/3, remember 2/3 squared plus cosine squared equals 1. So we can simplify this, bring this to the other side, and we will end up with cosine squared theta equals 5/9. Remember, we just squared this and then subtracted it. And then after you do that, you're going to have to square root this, and you get cosine theta equals square root of 5 over 3. Now this is going to be useful because we can now use our double angle formula. Now we have the sine and we have the cosine. So if we're going to use our formula to find the exact value of the function of sine of 2 theta, then we're solving for what? Solving for theta. So we are going to write our formula again. Sine of 2 theta equals 2 sine theta cosine theta, and then we're going to plug each of our parts in. So sine 2 theta equals 2. Now remember, sine theta equals 2/3, so 2 times 2/3 times the square root of 5 over 3, which was cosine. That's a 5 there. And you will end up with sine 2 theta equals 4/5 over 9. And that's it. We're solving for sine 2 theta. We want to know the exact value of this function. And since we knew that sine of theta was 2 over 3, we plugged it into our formula, found cosine, went back to this original equation, and we now have our answer of sine 2 theta equals 4 times the square root of 5 over 9. Okay, and then our second example is going to be one of using cosine. So we need to now find that cosine of 2 theta. You have 3 different options for finding cosine of 2 theta. There are 3 different formulas that you can see in our PowerPoint and in your notes. But today we're going to use this identity because this works best with our equation. So we already know that sine equals 2 over 3 and cosine equals the square root of 5 over 3. this is a continuation of the same information that was given. So we're going to write our identity out. And now we're going to plug it in. So if you have cosine squared of theta, you're going to put in your cosine value and put a squared around it. It's really that easy. Just because the square is in between the cosine and the theta doesn't mean that it's not the same thing as cosine times cosine. So this is cosine, and if you square that, it's the same thing as cosine times cosine. Don't be confused by the look of this polynomial thing right there. The trig identity. We're editing that. And then we're going to subtract the 2 over 3. And we're going to square that. And you're left with the fraction of 1/9. So cosine of 2 theta equals 1/9. And that's it.